Continuation of question 3, it's D and E. So now I've got x to the n equals x to the n e to the minus x is what g of x equals, where n is any integers, so 0, plus or minus 1, plus or minus 2, etc. Write down expression for the second derivative. So I've taken my second derivative, and that's going to be somewhere down here. Second derivative of and I get the expression. I've hit simplify to get a nicer expression. Find the non-zero values when it's equal to 0. So I'm going to take my answer, set it equal to 0, and solve for x. And I get the non-zero, so I don't include that one, so I have x equals n minus root n and n plus root n. And now I need to complete the table for all the values of n where I get none, 1, 2, or 3. So straight away I'm thinking when n is negative, I'm not going to get any solutions because it's the square root of n. So if I take into account, what have I got? I've got x to the power of n e to the minus x, and I'm going to say given n equals -1, I can see that this is totally concave up and that's totally concave down. Analysis G solve, inflection, there are none. And I'm going to have the same case for all of the negatives, that I don't have any points of inflection. So for 0, n is an element of all real numbers. What happens if n is 0? I get e to the x, and that also doesn't have any points of inflection. Okay, so what if n is 1? Analysis G solve, inflection, there's 1. What if n was 2? I've got 1 there, I've got 1 there, so I've got 2. So now I've got n equals 3, and I can see 1, 2, 3. So n equals 3. N equals 4. My guess will be it'll be the same as the 2 because that's going to give me x squareds, x4, x6s, so x equals 4. Analysis G solve, inflection, there's 1, there's 2, so there's 2. And when n equals 5, I reckon there will now be 3. Analysis G solve, inflection, 1, 2, 3. So 5, 7, 9, 6, 8, 10. Therefore, n is equal to 2n plus, so 2n, given n is bigger than or equal to 1. and n is already defined as an integer. And this will be n is an element of 2n plus 1, where n is bigger than or equal to 1. That's when n equals 1, that's when n equals 0, and that's when n is negative. So that's all of the points of inflections. Now I used a graphical method in preference to exploring what's going on in here.